All right, good. Now let me answer a few of these questions. There was a question up here saying, talking about how you detect rootkits. Rootkits are in fact very difficult to detect. Now there are different kinds of rootkits. There are user mode rootkits that run like any other program, like Microsoft Word. And those might even show up in Task Manager or Activity Monitor, but they often try and hide. But the kernel mode rootkits that are more dangerous run in the heart of the operating system. So if you execute a command, like a directory command that lists all your files, it hijacks that request and runs it through a malicious process that lies. So your directory of files will not include the files the rootkit is hiding. So the rootkits can be very difficult to detect. A perfect rootkit would be totally undetectable. Really, the only way you ever detect rootkits is because the designer makes mistakes. And that's why rootkit scanners are difficult and not terribly effective. It's a difference with a root process. A system, you have processes running in the system before you log in. So there's an account more powerful than administrator or root, which is system. Before you log in, there are processes running and they run with no user account. So that's the system process, and that's typically where rootkits run in the kernel. All right, let's see. Can the dependency walker identify DILs? We talked about that. Socket versus kernel. Those are two different things. A socket is just a network connection. And raw sockets use that library we saw up here, the Berkeley standard sockets, WSOC. These are raw sockets where you directly connect to something and you control the packets that are sent one by one. That's the way the original Unix did it from Berkeley that defined the TCP/IP protocol used to make the internet. But it's not the most convenient for modern developers. They mostly use a high-level library like WinINet. But these are called raw sockets. And the kernel is just the part of the operating system which always has to be loaded in RAM and which has complete privileges to use the hardware. Everything else you run is in user land and it is limited in its privileges. So if you want to do something like put a window up on the screen touching the monitor, you're not authorized to do that. All you can do is ask a Windows API function to please do that for you. You're not allowed to change the contents of the kernel. And we'll play with that quite a lot as we go ahead. Then how does malware attack a DIL? Well, malware typically attacks by means of a DIL. The easiest way to get code to run on a machine is to trick a program into loading the wrong library. So it loads a malicious library instead of the real library. And we're going to do that several ways as we go ahead. So that's because since your program connects to an external module and runs it, that is the most inviting way and the most common way malware works, by using a DIL, a malicious DIL to inject the code. Could you use a KVM to fool a piece of malware that knows it's in a virtual machine? You might. Some virtual machines look at the name of the network adapter or other things like that to tell if they're in a virtual machine. And if that was the case, you might be able to use something like a USB network adapter to fool it. It just depends on the malware. Most virtual machines are not subtle at all, though. There are many clues. There are registry keys. The names of the virtual hardware have VMware in it and stuff like that. All right. What happens when a program imports all possible DILs from an OS? It would just be a big program. You know, you'll see even things like Notepad import hundreds of DILs. As far as I know, there's no limit to how many you can import. You can't hear me? Oh, you can hear me. Okay, good. Yeah, some people can hear me. Anyway, so good. Okay. That's important, though. Let me know that. I have sometimes started lecturing with mute on, and you have to tell me. Okay. Anyway, so I hope I've answered those questions. And let's do the last bit here. Okay, so DILs export functions, because they offer services to other programs. EXEs import functions from DILs, and both the exports and the imports are listed in the portable executable header. And so we saw these examples. All right, and so here's what a keylogger might do. Now, a keylogger wants to steal key presses. So it will import user32 and then use this function, set Windows hook. Now, we are going to come across a lot of this as we go ahead. Microsoft is an all-purpose operating system, which is, by the way, pretty dangerous in the first place. And what's even more dangerous is that Microsoft supports backward compatibility. Now, this is real important for business purposes. If you run a company, you might have something you use every day, like a cash register that was written on Windows 3.1. And then you update the rest of your stuff to Windows 10, and you don't want to rewrite that. So Microsoft lets you run really old things on your network and old software on your machine. That is, of course, not safe, but it is essential in a business environment. Real companies have old stuff that they don't feel like upgrading. So that means Microsoft has a lot of ways to patch things. So hooking is one of those options. Suppose I want to put a fancy keyboard on a machine, like a Bluetooth keyboard, that's different than the keyboard that plugs in the back with a cable. Then I could use a hook process that will capture key presses and change the way they're handled. And so there's a bunch of these ways. So it is easy in Windows to say, before you do a normal activity, run this extra code, because you might have a different keyboard, a different monitor. You might have an antivirus process that says, wait, before you open that file, let me scan that file. So there's all these interrupt what you're doing and run some extra code over here. And of course, each of those processes can be abused by malware authors. So the Windows hook will hook the event in the Windows system that detects a keyboard has been pressed and then run some code. And that would, of course, be the keylogger recording that somebody pressed that. So it now exports keyboard proc and mouse proc to send the data somewhere. It uses register hotkey to define a special keystroke to harvest the data. This is one way you could make a keylogger. And we are going to make a keylogger later in the class. You'll see how to do it. And here's one with a packed program. So if you run a packed program, you'd see almost no functions. One from user 32 and a couple from kernel 32, as opposed to the hundreds you'd normally expect to see, because all you're seeing is the unpacker. All right. So anyway, here's the file headers. Here's typically what you see. Text is always there. Those are the actual instructions that the CPU executes. You haven't got anything if you don't have instructions. Otherwise, it's just a text file like a notepad file. Then you've got imports and exports in the R data section, data in the data section, and in the resource section, you've got things like icons and images and menus and strings. And you might have other sections, but you typically see those four. So here's PE View, lets you see this. Here's a program running. This is notepad.exe. So it's got text, data, resource, and a relocation section. And down here you can see in them. And here it shows you the time date stamp, which tells you the time down to the second when this program was compiled. And that turns out to be useful for attribution. If you find a malware from an advanced persistent threat actor, you can look at the time date stamp, and if you have 3 or 4 files that were all compiled at exactly the same time, then they're probably from the same maker of the malware. They're part of the same version of some malware, and it's often used as part of attribution because most malware is written by normal 9 to 5 workers in the daytime, so you can get some clue about what time zone the malware came from that time. That's the time date stamp. Of course, it can be wrong. It's not verified anywhere. For example, Delphi just fills this in with a fixed date, and you could modify it. But if it's just automatically generated by the compiler, which is normal, then it will be an accurate measure of when that malware was compiled. So when you look at the section header, you'll see the size in RAM and the size on the disk. They're normally equal, but packed executables, they would be different. Yes, the time can be made up. All this stuff can be falsified, so you can't trust any of it too much. But if you were to change things like these sizes too much, then it wouldn't run anymore. But yet the time is like a label. That's why I thought it was kind of hilarious. There was a contest at DEF CON a few years ago where you would modify malware to get past antivirus, and you would discover a lot of antivirus uses the most horrible things, like it would go to the properties sheet of the malware and look at the name of the author, and that was the antivirus signature. So all you had to do was change the name of the author and it would sail through. I did a project years ago where I snuck some malware through antivirus with Python versus Norton. It is incredibly easy to fool antivirus software. Antivirus software is very shallow in its analysis of things. And so I was horrified at first, but then I realized the only purpose of antivirus is to block a list of known malware. Heuristic AV is pretty much a swindle. Heuristic AV tries to detect malicious activity. See, the problem is it runs your malware in like a little virtual machine or something. This is what FireEye does on the wire. It runs your malware in a virtual machine and looks for malicious behavior. So the problem is a lot of innocent software will look malicious now. Like just something you download that happens to like unzip when you run it, they'll say, oh, that looks like malware when it isn't. So in practice, the heuristic settings are always set so insensitive that they don't do any good. And another trick, which I learned in that Python versus Norton project, is it can't wait forever, right? It launches the malware, it waits to see if it looks malicious. It can only wait a few seconds. So all you have to do is to delay your malicious activity by 10 or 20 seconds. And then the heuristics will never detect it. So, heuristic is pretty much a pig in a poke. It's got to be. So that's why I say amateurs say that antivirus is protecting them. Professionals say antivirus is not even in the top 10 of defenses. You still need it. Antivirus stops the lowest level attack where somebody sprays 1 million copies of the same file to everybody in email. It will stop that, but it won't stop anybody even a little smarter than that. So you have to have other defenses. Your number one defense is updates. Updates patch the known holes, so the only attackers that can get in are people who can find stuff that isn't known yet. And that's a pretty high level of attack. So, but anyway, that's why you got to realize what antivirus is. Antivirus is like, a 3-foot fence around your building. Using AI to stop malware. No, a lot of people are talking about AI right now and expecting it to stop malware. I'm pretty skeptical, but I think we are going to have it. They're selling the products now. I think we will use it, but the bad guys are already using AI to write malware. So, it's just the next thing. This is the way life always is. The crooks get bigger guns, so the cops get bigger guns, so the crooks get bigger guns. That's the way it is. AI will definitely be there. There will be an AI war before long, and we will all get used to using it. I think it won't be a big game changer right away, but we're all going to have to learn it. AI is absolutely coming. Anyway, let's see if there's anything else worth mentioning here. So there's an unpacked file. So the virtual sizes here and the size of raw data, and you see they're very much the same. A6, HC, and A800, very much the same. But here's a packed program, so where some of these sizes are 0 and these are bigger. Anyway, is the Python malware compiled to exe? Yes, I compiled it to exe at that time. If you ran it as a Python file, then I don't know if any malware detector would detect it at all, because most machines don't run Python, not Windows machines, which is mostly what you're worried about. But what a lot of people do now is they run, what's Microsoft's new command line? PowerShell. There's a lot of PowerShell malware, and I think antivirus will pick that up. The Python I was using was compiled to exe. All right. And so Resource Hacker is a common tool used by old script kiddies to play with games and stuff. You can browse the resource section and change the strings and icons and menus. We'll use it a little bit. Resource Hacker lets you see what's inside files here. You can see all the little pictures. So this is calc, and you see the various pictures of the calculator here. They're stored as various icons here. So you can modify them with Resource Hacker. And we're going to use a lot of tools to pry inside executables and mess with them. You'll see it go by. So I got the last Kahoot here. Let me bring it up here, 1C. All right, and now I'm going to share it. Yeah, that looks right. All right. That might be it. Nope. Okay, I'll wait. Might be a few more. All right, that's apparently it. All right. So what technique makes an executable large? That's static linking, where you put a copy of the library inside your executable. What technique is most common for Windows? Dynamic linking, DLLs. All right. Which of these libraries uses FTP? Okay, this is the normal way you would use FTP. Now, you could, in principle, use WSOC and make the calls one by one, but normally you'd use WinINet to use a high-level library like FTP. All right, which of these libraries is required to show a pop-up box with buttons? Okay, that would be user 32 for the user interface. All right, which library is not normally used by EXEs and therefore suggests that you got malicious software? NTDIL is the low-level private API that's only supposed to be used by internal Microsoft code, not by developers. They're supposed to use kernel 32. All right. All right. HEMA I've seen before. Good. Learner will have to tell me the real name if they want their points. And Abacus, I know who that is. All right. Good. So I'm going to stop the recording, but I will stick around to answer questions.